Okay, so this is our last example, and it's a little bit different. They've really specifically made this problem to be a certain way. You don't always see a lot of examples of these kind, but we'll show you. Sometimes it's good to think outside the box a little bit. All right, so it says factoring an expression with fractional or negative exponents. Well, you can see you've got a negative exponent there, and it's also a fraction, and you've got a fraction there as well. Now the idea is to look at the whole thing in a big picture format. And do you see something that they have in common, like a GCF? We'll see how they both have x plus 2 here. What I'm going to do is I'm going to factor out x plus 2 to the negative 1/3, which seems weird. Like I said, we don't, always see something like that. Now what happens if I do that? Well, I'm going to put a bracket in just to make it a little bit easier to see what's going on. In the first term, you have left 3x, right? Because the x plus 2 to the negative 1/3 came out. Plus, and then you're going to have a 4, and then what? So that's kind of the tricky part. Let's see how I can write this so you can think about it. If I had x to the negative 1/3, and I wanted to multiply it by something, x to something, so that I would get x to the 2/3, what would that something have to be? It would have to be 1, right? Because you're going to add those exponents, and a negative 1/3 and a positive 1, that'll get me a 2/3. You might want to rewind that part and go over it again, because it's a little bit different, okay? I guess you could think about, well, you're factoring it out, so you're subtracting that exponent. So we're saying, what's 2/3 minus a negative 1/3? 3/3 or 1. And I think it was easier to think about it the first way. Anyway, so what do I have left here? I have x plus 2 to the first power. So think about, okay, multiplying there, that's not a problem. Maybe. And then multiplying here, you have these bases that are the same, and so you'd have to add negative 1/3 plus 1, and that's how you would get the 2/3, which is right there. Okay? It's a real, think about it, like, let it mull over, let it marinate a little bit. Okay, that's what you get. Okay, now what does all that mean? Well, x plus 2 to the negative 1/3. And then inside here, I'm going to have 3x plus 4 times x plus 2. I don't need that 1 for the exponent. And then I'd want to simplify that. So I'd have 3x plus 4x plus 8. And then I'm almost done. I'd have x plus 2 to the negative 1/3 times, remember this was a section on factoring, we want it to be multiplication, 7x plus 8. And that's the answer. It's kind of different, but that's the answer for this problem. What does that really mean? Like if I were really to think about what does that mean? Let's be happy with the answer, but now let's talk about, like, if you came across this on the street, like, what are we really talking about here? We're talking about a 7x plus 8 in the numerator, and then we're talking about the cubed root of x plus 2 in the denominator. That's what it means right there, but I just point that out for you. Okay, don't worry about these problems too much. I don't think you're going to see a lot of them, but that's the example that they gave, and I decided to go through it.